Good morning, guys. Am I audible to all of you?
Yes, sir. Good morning, sir.
Good morning, sir.
My screen is also visible to all of you, right?
Yes, sir.
Okay, we have a long break, right? Okay, that's happened. Okay, so in the last few sessions, so we have started our discussing related to multi-threading, right? And in our previous session, we have discussed something called thread synchronization, and we have discussed if we are not protecting the shared resources in a multi-threaded environment, then what happens? We see that we will get some inconsistent output, or you can say we will get some inconsistent behavior of the application, right? So it is important for us to handle the shared resources in a multi-threaded environment. And we have started our discussing that one of the mechanism that available in .NET framework is called a log. By using a log, we can handle the shared resources in a multi-threaded environment. If we are protecting the shared resources using the locking mechanism, then what will happen at any given point of time, only one thread can access the critical section or the shared resources, right? That is what we have discussed, right? So we have only discussed the basic concept, right? What is log and how to protect the shared resources. But from today onwards, we are going to discuss all the thread synchronization mechanisms in detail. What are the different thread synchronization mechanisms are available? Why we have different types of mechanisms, right? What are the things you can do with one of the mechanism? What are the things you cannot do, right? All these things we are going to discuss in detail from today onwards, right? So let's start our discussion using one of the concept called the log, right? We have already given an introduction to log in our last session, but today we are going to discuss this log concept in detail. What is exactly log? How internally this lock work, how internally this locking mechanism is implemented, right? What are the things you can do with lock? What are the things you cannot do with lock? All these things we are going to discuss today, right? So so in the interview, you might get one question: why do we need to protect the shared resources in a multi-threading environment, right? And we have already discussed this concept. What we discussed now, if we are not protecting the shared resources in a multi-threading environment, then what we will get? We will get inconsistent behavior or output of the application, right? So it is important to protect the shared resources. Otherwise, your application behavior is going to be inconsistent, or you will get some output which you cannot imagine, or you can say unexpected output, right? So like log and monitor are interrelated to each other. So that's why I'm going to discuss these two concepts in today's session. So using log and monitor, we can provide thread safety to a multi-threaded application. Thread safety means providing some mechanism so that we will not get some kind of inconsistent behavior or inconsistent output. So using log and using monitor, we can protect our shared resources in a multi-threaded environment, right? And both log and monitor provide a mechanism that will ensure that only one thread is going to execute the critical section code, or you can say the shared resources at any given point of time, to avoid inconsistent behavior and outcome, right? See, let me start with the example that we have already discussed in our previous session. So we have discussed this example, right? So in this case, I'm not using multi-threading. It's a single-threaded application. The main thread is going to execute the display method 3 times. And we know that single-threaded application means what? Now, once this method execution completed, then only it will execute the next method call. Then it will execute the next method call. Until and unless this method execution not completed, it will not execute this method call. This is nothing but your single-threaded application. And can anybody tell me, in this application, how many threads are going to execute the application code?
One thread.
One
Okay.
thread, main thread.
Only main thread. This main thread is going to provided by the process, right? So because to execute each and every application, operating system allocates something called process, and as part of the process, by default, one thread is going to execute our application code, and that thread is nothing but our main thread. So main thread, you can consider it is the thread which is going to provided by the process, right? And any thread that you are going to create it inside your application, that are nothing but your internal thread you can consider, and internal thread is going to be created by the main thread only, right? Or you can say internal thread means it is going to be created by another thread. It might be a main thread or it might be another thread, right? So in this case, this is a sequential execution. And in this case, if you will run the application, then you will get the output as expected. Because why? Because the execution takes place sequentially, right? So you can see the output you are getting as expected, and this is expectable. Why? Because this is a sequential execution. Until and unless this method execution not completed, it will not execute the next line of statement. This is fine. This is fine. Now, what happens, right? If you trying to access the shared resources in a multi-threaded environment, right? In this case, which one is the shared resource? This display message, what we are writing here, it is nothing but the shared resource. Because why? Now, because this resource is going to be invoked by three different threads, T1, T2, and T3. So we are having three different threads, and all these three different threads trying to access this shared resource. And in this case, you cannot predict the output, right? In this case, you cannot predict the output. And as we are not protecting our shared resource, the behavior or the output is going to be inconsistent, right? So you will not get the output what you are expecting in this case, right? Instead, you will get some kind of a different output. You can say this is the output. Why we are getting this inconsistent behavior or inconsistent output? Now, because we are not protecting our shared resources. As soon as you are not protecting the shared resources, these resources simultaneously or concurrently accessed by multiple threads. As multiple threads accessing this resource concurrently, so you will get some inconsistent output and inconsistent behavior. Then what is the solution? We have discussed in our previous session, lock. By using the locking mechanism, we can protect the shared resource, right? So that at any given point of time, only one thread can enter into this critical section, or only one thread can access the shared resource, right? That is what we have already discussed in our previous session, right? So what we have discussed, now we have discussed we need to create one object, right? So you can create any kind of object. Here I'm creating an object of using the object class, which is the super class, right? I'm creating one object, right? And by using the log, I'm providing that object, and as part of this log, I'm writing the critical section code, right? So code that you do not want to access by multiple thread concurrently, that you need to put inside this log block, right? This is what we have discussed, but we have not discussed what is this lock mechanism, right? How this lock mechanism is implemented, and how this lock mechanism is internally work. That is what we have not discussed in our previous session. Today, I'm going to discuss what is this lock mechanism, how this lock mechanism is internally implemented, right? But this is what we have discussed. What you need to do, you need to create one object, right? It's always better to make this object as read-only and private, so that no one can change or this object. Private means from outside the class. This variable cannot be accessed. It should be used within this method only, right? So just you need to create a log object, right? You need to pass the object to which the parameter of this log construct, right? And then you need to write the code. So what you will do, it will log this object, right? As soon as it log this object, only one thread can enter into this critical section. No other thread can enter into this critical section, right? Once the thread which is executing this critical section release the lock, then only another thread command execute this lock statement, right? So today we are going to discuss what is this lock in detail, right? What is lock, right? So according to Microsoft, the lock statement occurs, the mutual exclusion lock for a given object, execute a statement block, and then release the lock. While the lock is held, the thread that holds the lock can again occur and release the lock. Any other thread is blocked from occurring the lock and waits until the lock is released. What it means, first of all, this lock will occur an exclusive lock. Exclusive lock means only one thread can execute the critical section code, right? One thread occur an exclusive lock, then that thread can enter and execute the code that is present inside this critical section. And at that time, all other threads will wait. All other threads will wait until this thread, which one is currently executing the code, release the lock, right? How it occurs the lock, how it is going to release the lock, that is what we are going to discuss. I will show these things practically. But for now, you just remember when I am writing this statement, behind the scene, something is happening. What is happening? Behind the scene, it is occurring a lock on this critical section. After executing the statement that is present in the critical section, it is going to release the lock, right? The point that you need to remember is once the thread occurs the lock, let's assume that thread 2 occurs the lock, right? Thread 2 occurs the lock. So once thread 2 occurs the lock, means behind the scene, thread 2, behind the scene, some mechanism is executing. And when that mechanism is executing, thread 2 occurs the exclusive lock on this block. Exclusive lock means only that thread can execute this block. At that time, at the same time, thread 1 and thread 2 will wait. How long they will wait? Now, as long as thread 2 executing the critical section of code, and once the thread release the lock, how it is going to release the lock, that we will see. Once thread 2 release the lock, then only the other thread can occur the lock. But the point that you need to remember, other thread, in this case, 2 threads are available, but both the thread cannot occur the lock. Only one thread out of this 2 thread is going to occur the lock. Which thread is going to occur the lock? That we cannot predict. That is going to be decided by the operating system, processes, and all these things, right? That is not in our control, right? So this is the point that you need to remember. When you want to synchronize thread access to a shared resource, you should lock the shared resource on a dedicated object instance. So whenever you are going to use the locking mechanism, you need to lock the shared resource on a dedicated object instance. What it means is saying, now whenever you are going to lock the shared resource, then you need to lock the shared resource on a dedicated object instance. So this is nothing but your dedicated object instance. This object instance only purpose is to lock the critical section. You should not use this instance for other regions, right? This lock display method, what you are created, right? This object should be used only for one purpose, and that is nothing but to lock the shared resource. It should not use this locked object for other purposes, right? So how you are going to create the dedicated shared object? Thus, you can use like this. Public read-only object lock object equals to new lock object, right? And a private static read-only. So you can create a private read-only or private static read-only. So that basically depends what type of method is this. If this is a static method, you can create a static read-only object. And if it's a non-static method, so no need to create this dedicated object as static, right? For example, suppose I'm creating one non-static method or display one, right? So what I can display log display method one. So in this case, no need to declare this as static. You can declare this as a non-static. So how many ways you can create the dedicated object? There are 2 ways. First of all, you can create that as a static read-only object, and if you are going to use this inside a static block, and if you are going to, if your shared resource is within a non-static block, you can create a method like this. Even you can also use this static object inside this lock method. That is also fine. but the other option is not possible. You cannot use this directly because this is a static block. From a static block, you cannot access a non-static member directly. To access a non-static member, what is required? It required a instance. But from a non-static block, you can access the static member directly. Object is not required, right? That is the point that you need to remember. So how to create a dedicated object means we have two options. Either you can create a static read-only object or you can directly create a read-only object. Then question is why I'm going to mark this as read-only? We are going to mark this as a read-only because I do not want this object to be altered or modified by anyone else. This is fixed. The purpose of this object is fixed. It is going to be used only within the lock, right? So I do not want anyone to modify this object. This is the reason why I'm marking this as a read-only. Read-only means that is finite. While you are creating, you need to initialize, and once initialize, you cannot modify this value. Clear?
So, oh crap. What was that?
Please mute,
So,
close your video. Only audio is available. So
I
don't
pressed the video by
enable.
mistake. I'm sorry. So I have a question. Like, if they wanted, I don't know how to exit that video. If they wanted to like modify it, how would they like? If you didn't set it as read only and they wanted to modify it, how exactly would they modify it? Is my
So modified means this is a lock. So which type of variable is this? Object.
It's an object.
So object means can I store some integer value inside this variable like this? Yes.
Yeah, you should be able to store
Marking
integers
this
inside
as
of it. Yeah.
read-only.
Well, if it's not real,
Okay.
yeah. Okay, yeah. Now, yeah. Okay.
So if I'm not marking this as a read-only, then you can modify this shared or dedicated object, right? But I do not want that. I only want to use this inside this locking mechanism. So how I can make sure I need to make this as a read-only, right? Once you make this as a read-only, then you cannot modify that dedicated object. Clear?
Yes, thank you.
Yeah. So this is how this dedicated object is used for and how to create, right? And it is not mandatory. It is going to be object in any kind of a type, any type you can create, right? But most probably we are using object type, right? So this is, but that is fine. So we are creating this dedicated object and it's very simple and very straightforward. And by looking at the syntax, you can say that it's a static variable, it's a read-only variable, right? And its type is object, right? But how this lock is internally implemented, how this locking mechanism is work, that is what we need to understand. The lock statement internally converted to a try-finally block when we compile the code. The compiled code of the lock statement will look like below. How it is going to look like? It is going to look like below. You can say this variable temp new object. This object is nothing but your dedicated object, what you are creating here, right? And then there is a Boolean variable lock was taken, which value is by default false. See what code I'm showing here. This is the compiled code of your lock block, right? So you are written the lock statement here, right? After compilation, how this lock statement is generated, how this lock statement is generated in the IL code, that is what I'm showing here, right? So here this temp object is nothing but your dedicated shared object, what you are creating, that lock display is going to store inside this temp variable, right? And then this is a Boolean variable which value by default is set to false. And then you can see there is a try and finally block. Within the try block, there is a class called monitor. What is monitor class? We are going to discuss in detail, right, after this lock statement, right? Manually, what I'm showing here, that also we can write, that I will show you. But for now, just remember how the lock is implemented internally. So internally, it will create the try finally block. In the try block, it will invoke the monitor class enter method. And if you go to the monitor class, then you will see that there is something called enter method. There is something called exit method, right? And you will see that this is a static class As monitor is a static class, you will see enter and exit all are going to be static method only. So, okay, let's see monitor. So there is a class called monitor. And if you go to the definition of monitor, you will see that enter. And you can see this is the overloaded version he is using internally, right? Object and rep will, right? So you can see this is nothing but object and this is nothing but your Boolean type, which is referred by using the rep parameter, right? And exit method, you can see this is the exit method, what I'm showing here. See, so when this statement within the try block, it will convert your log statement into something like this. And inside the try block, it is invoking the monitor.enter method by passing two pieces of information. One is your object and another is your this rep log was taken. And as part of this body, whatever code you have written here, right? As part of this body, whatever code you have written, that is going to be placed here. And when this monitor.enter method execute, it will only give the exclusive log to a single thread only. Once it give a thread, once it allows one thread to enter into the critical section, if any other thread trying to enter into the critical section, then it will not allow. It will put them in the waiting queue, right? Or you can say it will put them into the ready queue, right? And once this once one thread complete its execution, right? And we have already discussed in our exception handling, finally is the block which is going to be executed guaranteed or not, whether whether your try block throwing some exception or not, whether the exception is handled by the catch block or not. Finally block is going to be executed definitely or not.
Yes.
Right?
Only.
Right. That means once your try block execution completed, whether the execution completed successfully or whether it is going to throw some kind of error or not, that doesn't matter. After this try block, 100% this final block is going to be executed, right? Then what will happen inside this monitor.enter method? Now, when this method is executed for a thread, if it acquires the log, then this log was taken is going to be true. By default, what is its value? False. If it gives the access to the particular thread, then that value will become true, right? And once that value become true, then that is going to be executed by this, that thread is going to execute the body. And once the execution of the try block completed, then it will come to the final block and it will check if the thread, if block was taken, it's true or false. If it is true, that means lock is already assigned to some of the thread, right? One of the thread. Let me call this exit method. And once it call the exit method, right? And what it is passing to the exit method, the object what you are creating, that object it is passing to the enter method, and that object it is passing to the exit method. So when the exit method is executed, right? The thread which acquired the lock, that thread is going to release the lock, right? Once this statement is executed, the thread will release the lock, and as soon as it releases the lock, then other threads which are there in the queue, right? Then from those other threads, one of the thread will acquire the lock, and for that thread again, the same process is going on, right? Guys, understood or not?
I actually have two questions, sir. The ref lock was taken inside the when you inside the enter method. Is it passing the value false or is it passing the reference to?
See, so first of all, tell me why we are using ref. Ref means
Using a
we are
reference.
expecting. So it's a reference kind of value, right? We have ref and we have out parameter, right? And whenever we want the value to be set by the calling method, then at that time we need to use the ref and out parameter, right? So in this case, when we are using ref means what? It means it is not mandatory to set the value by the enter method. If I'm going to use out, then it is mandatory. But in this case, this enter method, what we are calling here, he is going to set the value of this parameter. And that updated value, if you want to get back, then at that time you need to use ref or out, right? Okay, to make you understand, what I can do is, okay, so I'm creating a static method, static void sum method, right? And what I'm doing, ref integer x, right? And what I'm trying to do, x equals to 100, right? And what I'm trying to do here is, let me comment these statements.
Yeah, I think I see what you're trying to do.
Sorry,
You can change it, yeah, by the reference. I think what you see. I think
suppose I'm declaring one variable integer some y, right? Integer y equals to 10, right? And then I'm calling this sum method, right? And while I'm calling this sum method, you cannot pass y. What you need to pass, you need to pass ref of y, right? And then if you write this console.writeLine statement, right, and y, then you will see that what will be the y value in this case. The value which you set here, or the value
Should
which
be
is set by the sum method.
good, right?
Which one is the, which value it is going to print?
100.
100. Why? Because that rep means it is going to get the value from the calling method. And the calling method responsibility is to set the value. You can see here you are getting 100. The same thing is also here, right? So here we are calling this enter method by passing this parameter, means what? This parameter is going to be set by the enter method. If it occurs the lock, see, at the same time multiple thread can execute this enter method. 3 threads execute the enter method. But all the 3 threads will not occur the lock. Na? Only one of the thread will occur the lock. The thread which occurred the lock, for that thread, this lock was taken value is going to be set as true. And for other thread, the value is going to be set as false. Right? We will see this practically, right? Once we discuss monitor class, we will use this parameter practically and we will see this. Right? So the lock was taken means this parameter is going to be set by the enter method of the monitor class. For the thread which occurred the lock, for that thread it is going to set as true, and the thread which doesn't occur the lock, for that this parameter is going to be set as false, right? And then it will check if the thread, current thread, or which one is executing your code. If for that thread this lock was taken, then it will exit, it will call the exit method. And once it call the exit method, then you will see that, right? Then you will see that the lock is released. And once the lock is released, then only other threads which are there in the queue, they will occur the lock, right? And now if you, okay, let me delete this thing, right? Now if you build the solution, and if you go to the ILDSM tool, right, then you will also see the same thing. Okay, I have built the solution. Okay, go to the location where the exe is generated, right? Now open the ILDSM tool. How to open the ILDSM tool? Go to developer command prompt, then type ILDSM, right? Once you type ILDSM, then go to the location where your exe file is generated and open that exe file. And once you open that exe file, then you will see this thing, right? And where you have written your code, the log mechanism you have implemented inside the display message method, right? So open the display message method. And once you open the display message method, then you will see that there is something called a try block or not. There is something called finally block or not, right? And inside the try block, it is calling the monitor class enter method by passing 2 parameter. One is of type object and another type of boolean ampersand or not. Boolean ampersand means it is a reference type, right? And within the finally block, is it calling the monitor class exit method by passing 1 parameter of type object or not?
Yes.
Right? and this is nothing but the code, right? Welcome to the world of .NET, right? And inside this, we have written some kind of a thread.slip, right? You can see welcome to the thread.slip and world of .NET. That means the same thing is written here now. Welcome to then thread.slip, then world of .NET, right? That means within the try block, first of all, it will call the monitor class enter method. And once it call the monitor class enter method, then any of the thread will occur a lock. The thread which occur the lock, that thread is going to execute this piece of information. Once the try block execution completed, it will come to the finally block. And inside the finally block, it is going to execute the exit method of the monitor class. And once the exit method of the monitor class execute, then it will release the lock, right? Once it release the lock, then the thread which are there in the queue, they will get a chance to activate the lock. This is how the lock mechanism is worked in .NET framework. Is there any question from anyone? How this lock is implemented internally?
Honestly, so I just had one more question. Since it's like in a try and a finally block, right? What will happen if an exception happens inside of it and there's no catch?
See, if you are writing this code, so this is your code, right? And if your class is throwing some exception, then you just tell me whether this final block is going to execute or not.
Yes, it will execute for sure. It would just skip down there.
Yeah, that is fine. So if your try block throwing some exception, then definitely your final block is going to execute, and definitely this statement is going to be execute, right? If the lock is accurate, then this exit method is going to be executed. In this case, cache block is not required. If you are implementing try cache, then you have to write the code, right? You know, this is my code. And if you are sure, if you are not sure that some of the exception is going to be raised from this statement, then you have to write your try cache now. Right? So you have to write the code like this, right? So this is your custom code, right? And this is the code you have written. And this code is the generated ILDSM code. He only put this try and finally block. Whatever code you have written here, this code will be put inside the try block, and inside the finally block, it is going to exit. It is going to exit or release the lock, right? And it is up to you, right? If you are writing your code, then if there is some chance of getting exception, then as a developer, it is your responsibility to write the try catch finally, right? What .NET framework you will do is, he is going to do only these two things, right? If you are using lock means, you will put one try block. Inside the try block, you will call the enter method of the monitor class. And after that, whatever code you have written, that code is going to be written, right? And in the finally block, he is going to release the lock. If you are not handling any exception, right? If you are not handling the exception, but there is a chance of getting exception, right? Then that exception 100% will throw. That exception is 100% is going to be raised. But even though the exception raised, the final block is going to be executed. That is what we have already discussed in our exception handling section, right? So using try catch explicitly, it is as a developer, it is our responsibility, right? But for .NET framework, he is not going to do any kind of exception handling mechanism, because he is not putting anything for your code or critical section block. He is just converting this statement. What you have written log, right? He is just converting this statement to like this, right? So what he is going to do, he is just trying to do monitor dot enter method, right? And within this method, he is passing this object, right? And then he is just putting this code, right? And he is not writing this final block. He is just writing this, and he is just writing the monitor dot exit method, and he is just calling this. So this is what he is converting, right? We'll see this monitor class in detail. So he is just converting this statement. If exception occurred, right? Then that means the logic what you have written is wrong, right? If you are written some wrong logic, then do you think that that is going to be handled by the .NET framework? No, that will not be handled by the .NET framework. That means if you are writing some code and if you are sure that some exception will occur at runtime, then you have to write the logic, right? Try catch or any kind of exception handling mechanism you want, you can write. Clear?
Yes, thank you.
Yeah. So this is how the lock mechanism is implemented, right? See, in this case, what we have shown you, in this case, we are protecting one method, right? So in this case, you can see all the code what we have written inside this display message, right? That is what we are protecting. So protecting means what? Shared resource means it is not always going to be a method. Sometimes it is going to be a some shared variable, right? So you can protect the shared resource. Protect the shared resource means protect the shared method, or you can also protect the shared variable, right? In this case, you can see I'm creating one count variable, right? In this case, this is my count variable, and that variable value is going to be incremented by this increment count method. And the logic is very straightforward. Here I'm creating one big for loop. This loop is going to be executed this number of times, and within this log count I'm creating one log a dedicated object, and I'm using that object as part of this log. And within this log block, I'm not putting all the code, right? Within this log block, I'm only putting my shared resource. This shared resource is going to be shared by multiple threads. And you can see I'm creating 3 different threads, and all these 3 different threads trying to execute this increment count method. So trying to execute this increment count method means they are going to execute this for loop. That means they are going to increment this count variable. Yes or no? So in this case, so in this case, if I'm not putting this as part of my log, then what will happen? Right? So in this case, as I'm not putting this shared resource inside my I'm not protecting the shared resource, then all these 3 threads, right, trying to access the same count variable concurrently or not? Yes, or no? So that means what? Now in this case, as this loop is executed for this number of times, and as I am calling this method 3 times by using 3 different threads, and as this for loop is executed for this number of times, then what is my expected value on this count variable? This is my expected variable or not?
Yes.
Yes or no? Suppose this loop is going to execute for 10 times, right? And if this 10 times means it will increment the counter variable from 1 to 10. Again, this loop execute means it's a static variable. So again, its value become 20. Again, if this method is called, that means the value will become what? 30. Yes or no?
Yeah.
Right? Okay, so let me do one thing. Okay, let me comment these things. Right. Now I'm calling this method 3 times. So what will be the output in this count variable? The variable output will be this one only. Yes or no? Because it's a sequential execution. Now I'm not using multi-threading. So sequentially it will execute the increment. Okay, this application will not run. We have to close this one. We have to close this one. Okay. Now you will see that the output is going to be this one. That is the expected output. Why? Because in this case, this code block, right? This method is not executing concurrently; it is executing sequentially, right? Once this method execution completed, it will make the value as 1000. Once the second time execution completed, it will make the value as 2 And when this third statement executed, it will make the value as this one, right? So that is what we are getting the output. Now what happening? Now I'm not calling this method sequentially. I'm not calling the increment count method sequentially. I'm calling this method by using three different threads. Three different thread means what? Concurrently. And when this method is executing concurrently, this variable, right, is going to be shared or not. This is a shared variable, right? This variable is going to be accessed by all the three different threads. And in this case, you cannot predict the output, what value will be the count variable. See, every time you run the application, you will get a different output. So currently I'm getting this output. Okay, let me run this application once more. You will get a different output each time you run the application. See, this is a different output. Why? Because currently this variable is not protected. It's a share variable. Its variable value is going to be shared by multiple threads, but we are not protecting this variable. If we are not protecting this variable, then a multiple thread can try to access the value. If multiple thread trying to access the value or trying to modify the value, then the output or the behavior is going to be a different one. It will not give you a consistent behavior. It will give you some inconsistent output, and that is what we are seeing here. Right? Then what we need to do? We need to protect this shared variable. So in this case, in previous example, right? If you look at our previous example, then in our previous example, we have protected the complete method. You can see all the code what you have written, we have written inside this display message. We have protected all the code. But in this case, we are not protecting all the code. We are only protecting this count variable. So the point that you need to remember is log, you can protect the whole method or you can protect part of the method, right? Part of the method means which section of the code, right? Which section of the method you do not want to be accessed by multiple threads. In that case, you just need to put those section of the code or those piece information of right inside the log. In this case, that is nothing but my count value. I don't want this for loop to be protected because for each thread, this for loop is going to be each time this method is called, this for loop is unique, right? Each time you call this method, this for loop is going to be unique. It is going to start from 1 and it will continue like this. But this count variable is not specific to this method. It's a shared variable. Its variable value is declared here, right? Each time you update the variable value, the updated value will be available to all other threads, right? So for that particular reason, we need to protect this resource. How will you protect? You need to create one object, dedicated object. You just need to pass that dedicated object to the log, right? And then you need to write the code or section that you want to protect. In this case, my count variable. So using the lock mechanism, you can protect the whole code block. You can also protect some shared variable or some portion of the code block, right? Now, with these changes, now if you will run the application, then you will get the output as expected, right? You will not get a inconsistent output. You will get the output as expected. Why? Because at any given point of time, right, this code block, this method is going to be shared. Sorry, this variable is going to be shared by only one. No more one thread can access this variable. Is that clear?
Yes, sir. One doubt here.
Yeah.
In this particular case, this lock and unlock will happen the number of times that the loop is going to execute.
Yes. Each time the loop is executed, right? That means, see, in this case, thread 1 executing this loop. And once this lock statement is executed, right, this code block, right, what you have written is not going to be shared by other threads. Once one thread completes this execution, then only other thread can access this code, right? In this case, 2 threads executing this loop for loop at the concurrently, that is fine. But this code block is not going to be shared. It is going to be executed by one thread. Once that thread completes the execution, then only other thread going to execute this code block.
Okay, so in total, like 30 lag times, the lock and unlock is going to happen for all 3 threads.
Exactly. So the number of times the loop execute, each time it will allocate this. And this is the reason why in this case you will get some bad performance. But how to improve this performance, right? If you are having some shared resources, how you can improve the performance? There is a concept called interlock, right? That's what we are going to discuss in our coming session.
Okay.
Who is enabling this closed captioning? Okay. So this is all about log statement in .NET framework, how the log statement is implemented internally. Is that any question related to what is this log, how this log is implemented internally, right? Right? No, I mean, if someone asks you how the internal working mechanism is, you need to tell, yes, the log internally create one try finally block. Inside the try block, it is calling the monitor class enter method, right? To acquire an exclusive log, and in the finally block, it is going to release the log, right? How it is going to release the log? By calling the monitor class exit method. So the point that you need to remember is, that means if you want to understand this log concept in detail, you should and you must understand the monitor class in detail, right? Until and unless you are not understanding the monitor class, then you will not remember this thing. See, you can see this is the log block, right? But how this log block is implemented, right? That is what you need to understand. And to understand that, what we need to understand, we need to understand the monitor class, right? So we have discussed that monitor and log, right, used to provide thread safety to share thread safety to a shared resource in the multi-threaded environment. We have already seen how to use the lock mechanism to achieve the thread safety. You can see this is the lock mechanism to achieve the thread safety. Now let us proceed and try to understand the monitor class, its important methods, and see how we can protect the shared resources using monitor class methods, right? So according to Microsoft, right? Okay, let me copy the hyperlink. Okay, paste it here. See, this is the monitor class, right? So monitor class definition check, it provides a mechanism that synchronizes access to object, right? And you can see they are providing some examples here, right? So according to Microsoft, monitor class provides a mechanism that synchronizes access to object. So what it means? It means like the log, we can also use this monitor class to protect the shared resources in a multi-threaded environment from concurrent access. If you are having some shared resource, and if you want to access that shared resource concurrently, then like the way you use the lock mechanism, in the same way you can also use the monitor class to protect the shared resources, right? And how it is done? Now this is done by acquiring an exclusive lock on the object so that only one thread can enter the critical section at any given point of time. So whenever I'm saying exclusive lock, what it means only one thread can enter into the critical section. Exclusive lock means only one thread, right? That is the point that you need to remember. The way we have implemented the lock mechanism, right? In the same way, we can use this monitor class, right? What we need to do is we need to create an instance of a monitor class, right? Then we need to call the we cannot create an instance of a monitor class. Why? Because it's a static class. Static class instance cannot be created. So how we can make this monitor class to work? Now this monitor class provides lots of methods, right? And using those methods, we can protect the shared resources. How we are going to protect the shared resources? Now this monitor class provides the enter method, right? By using the enter method, we can give an exclusive lock to a thread. This monitor class provides some exit method, right? By using that exit method, what we can do, we can release the log. This monitor class also provides lots of other methods. That is what we are going to discuss. You can see mainly this is enter method, exit method, each entered, false, false, all, try, enter, and wait.
These are the few categories of method this monitor class provides. What is this enter method? Now, when we invoke the enter method of the monitor class, it occurs an exclusive lock on the specified object. This also marks the beginning of a critical section or the beginning of a shared resource, right? Exit method means, see, I'm just sharing the definition now. We'll see all these methods practically, right? And when the exit method is invoked, what it means? It means it releases the lock on the specified object. This also marks the end of the critical section or the end of the shared resource protected by the lock object. What is this false method? Now, when we invoke this false method, right? See, what happens now? Assume that there are multiple threads. Assume that there are two threads is there, one thread executing, and you want the execution in such a way that after executing some part of thread, one method which is executed by one thread, you want other thread to start its execution. Then in that case, what we need to do is we need to use the signaling mechanism, right? Signaling mechanism is something like, suppose I'm writing one program, right? We have to complete 10 programs. So, and me and you, you means any one of you want to write the program. So the process is that I will write one program. After I write one program, I will give you one signal that you should write the one program. And once you complete one program, then you need to give me a signal, right? You need to give me a signal so that I can write the second program, right? Once I complete the second program, I will give you a signal, right? So that you can complete your second program. So in this way, two threads can simultaneously working and two threads can give a signal to other threads. One thread giving signal to other thread for the execution. Then in that case, we are going to use this false wait and false null method. Practically, we will see this. So what is this false method is going to do? It sends a signal to a thread in the waiting queue. What is waiting queue? I will show you, right? That it changed in the logged object, right? The logged object state is going to be changed. So be ready. Once I will give you the signal, you can start your execution. And when we call this wait method, right? When we call this wait method means it release the lock, and once it release the lock, then you have already given one signal to one of the thread. That thread is going to start its execution, right? So we'll see these things practically. What is this false and what is this wait method, right? And try enter means it is the advanced version of the enter method. When so like the way we have seen try parse, right? Similarly, this is a try enter method. That means one thread trying to enter into the critical section, right? If it enters, then this method is going to return you true. If it is not entered, then it is going to return you false, right? We will also see the example of this try enter method practically. So if you are not clear what all these methods are right now, don't worry, we will see all this method in detail, right? Now, how to use the monitor class that the syntax is given below. First of all, you should have one object. This is nothing but your dedicated object. What you used in the locking mechanism, the same object you are also going to use in this monitor class. So this is your dedicated object. You have to write the try and finally block manually. In the lock case, this you just need to write lock and you just pass the lock object, and internally is going to write the try finally block for you. But if you are going to use monitor class, that means explicitly you need to write all these things. So this is my lock, this is my dedicated object, this is my try block, and this is my finally block. In the try block, you have to call the enter method on the monitor class, say, and bypassing the lock object, right? And if you see this enter method, there are two different versions. So I will show you practical example of both these versions. What is this object obj and what is this ref boolean log taken? I'll show you practical example of this both the overloaded version, right? And here I'm using the first overloaded version. where I am going to pass my dedicated object as the only parameter. And after this statement, you have to write your critical section code or the shared resource you have to access here, right? And in the final block, what you need to do is you just need to call the exit method. And once you call the exit method, then it releases the lock, and then other threads which are waiting there to acquire the lock, they will get a chance to enter inside the critical section, right? Okay, let's see this practically. Right. So this is okay. So this is my print number method, right? And this is my dedicated object. So this is, first of all, you need to create one dedicated logged object. So this is my logged object. This is my dedicated logged object. So inside this print number method, right? So, okay, this is one print number method, and inside this main method, so what I'm creating one thread array, and this loop is going to be executed for 3 times. That means in this array, I'm creating 3 different threads. In any question related to this for loop, what is happening here? Guys, any question, guys? Any because I have not yet discussed this array concept. That's why I'm asking. Okay, let me simplify this. So what I'm trying to do is, so what code I have written here, right? So basically, I'm creating an array of threads and with the size 3, and here I'm creating 3 threads, right? Then what I can do is threads of 0 equals to T1, threads of 1 equals to T2, and the threads of 2 equals to 3. This code is clear. What is I'm doing here?
Yeah, an array of threads.
Okay, so basically I'm creating an array of threads, like the way you are creating integer array. Suppose you are creating integer ARR, then in this case, how many elements you can store? You can store 3 elements, right? 1, 2, like this. So the way I'm creating an integer array, so thread is also a class. You can see this is a class. So you can also create an array of a thread. So in this case, this array is of type integer. So which type of value you are storing here? Integer value. And this array threads array, which type of is this array? This array is of type thread. That means inside this threads array, what kind of value you can store? You can store value of this type. So this is type. So that means I'm creating one thread, I'm creating another thread, and I'm creating another thread. So 3 threads I'm creating, and in the 0th position, I mean in the first location, I'm creating thread 1. In the second location, I'm creating second thread, and in the third location, I'm storing the third thread. And we already know from our traditional programming languages like C and C++, array is always a 0-based index. That means the 0 index is going to store the first element. In this case, this is my 0 index and this is my first array. So what logic I have written here, right? So what logic I have written here, right? You can simplify by using this for loop. This for loop is also going to do the same, right? So inside this first location, right? First time I value is 0. Inside this first location, this array is going to store. So second time the loop execute, I value become 1, right? And I value become 1 means inside that location, this thread is going to be stored. So any approach you can use. So, okay, let me comment this one if you are getting confused, and let me open this one, right? So this is fine. So thread 1, thread 0, and let me comment this one. Right. So then what I'm doing here, okay, let me comment this one. This. Okay. So then as this array contains 3 threads, then what I'm doing here, I'm calling these 3 threads. I'm using this for each loop and calling the start method. And if you are still confused what is happening here, okay, let me simplify this also. So the above statement you can also write like this. Now it is clear. I'm creating an array of 3 threads, right? And I'm invoking these 3 threads. Or else what you can do is, okay, just comment this one, right? Comment this one. Now it is clear. I have not discussed the array concept. Let me remove the array things from there. Clear? Now it is clear.
Yes, sir. You can continue.
Right. So I'm creating 3 threads, and all these 3 threads are pointing to the same print numbers method, and I'm invoking all these 3 threads simultaneously, right? That means this print number method going to be invoked by 3 threads, right? Now, all these 3 threads trying to occur, okay, let me, all these 3 current that thread names trying to enter into the critical section, right? These 3, all these 3 threads trying to enter into the critical section. My critical section will be start here and end here, right? So you can see I'm writing monitor.enter, right? To this enter method, what I'm passing my dedicated object. And out of 3 threads, only 1 thread will occur the lock, will occur an exclusive lock. The thread which occurs the exclusive lock will enter inside the critical section, right? Out of 3 threads, you will see 1 thread enter into the critical section. That thread is going to execute this for loop. Each time it is delaying the execution for some 100 milliseconds, right? And once the execution completed, right, it is going to release the lock, right? It is going to release the exclusive lock. And how it is going to release the exclusive lock? By calling the exit method. And once this exclusive lock is released, and we are printing the statement exit from critical section. And once 1 thread exit from critical section, then you will see that another thread will enter into the critical section, right? And in the same way, it is going to operate, right? Let me run the application and show you the output. Okay, give me 1 minute, guys. Right. So you can say child thread 2 trying to enter into the critical section. So first, which thread got the chance to execute this print number method? Guys, in this case, first child thread 2 trying to enter into the critical section. What it means? It means thread 2 now got the chance to first got the chance to execute this print number method, and child thread 2 entered into the critical section, right? Child thread 2 enter into the critical section. That means that the child thread will got the lock, and that child thread 2 enter into the critical section. But after then, you can see child thread 1 trying to enter into the critical section. This statement is printed. Child thread 3 trying to enter into the critical section. This statement is printed. But the statement which you have written inside this critical section, they do not get chance to execute. Only once child thread 2 complete its execution, then only one of the thread from 1 and 3 will occur the lock, and they will enter into the critical section. Say in this case, child thread 3 trying to enter into the critical section. 0, 1, 2, 3, 4. Child thread 2 exit from the critical section. So once child thread 2 exit from the critical section, then only child thread 1 entered into the critical section, execute the for loop, child thread 1 exit from the critical section. Once child thread 1 exit from the critical section, then child thread 3 entered into the critical section, execute the loop and exit from the critical section. Right? So what it means that all the 3 threads can execute this code. That is fine, because this is not my critical section. What is my critical section? My critical section code is started from here. Right? My critical section code is started from here only. Right? Once I execute this. So this information you can see at any point of time, only one thread is going to execute. First child thread 2 execute the loop. This loop is executed, then exit from the critical section, right? Then child thread 1 enter the critical section, execute the loop, exit from the critical section. Then child thread 3 enter into the critical section, execute the loop and exit from the critical section. Is that clear? How this monitor class enter and exit method works?
So one doubt here, like only if the thread is allowed to take the resources or like taking the crucial method here, then only it will enter the try, or for anyhow it will enter the try method.
See, first of all, this statement can be executed. Say, thread 1 start, right? Thread 1 will get some time. The thread 1 will execute this statement. Thread 1 will execute to this statement, right? And the thread 1 execute this statement, right? And once the thread 1 executing, right? At the same time, this thread, if you allocate some resources to thread 3, then thread 3 will execute this statement. Thread 3 will execute this statement. But while thread 3 executing this statement, can you mute your sound because some background noise is coming? Okay. So when thread 3 is execute this statement, in this statement, he will not acquire the lock, right? He is in the waiting list. So he cannot execute this code what you have written until and unless the current thread which is executing this statement release the lock. Once the thread release the lock, then only it acquire the lock and it will execute this statement. Right?
Okay, means like the statements after the monitor dot enter is considered as the closed loop, and once the
Closed
thread,
loop also. So can you tell me what is closed loop?
like suppose in the case of
So
lock,
don't use those word closed loop, all these things. Consider this is nothing but your shared resources.
no, but it is not
Okay.
closed, no. So how suppose if it like this, whenever it enters the monitor dot enter log print numbers, and it will not and the lines whichever written after that is all like uh, is all logged for that particular thread, is it?
Exactly.
Yeah, so previously in case of lock, we were putting it in closed loop or in a method, to make sure that only once, only if it is checked, then it will enter that closed loop. But here it is just a statement. After that, line of statements are there.
This statement will taken care everything, whether the thread will go and execute further statement or not, that will decided by this statement. And coming to your point, that is the log was taken or not, by checking that value, we can also do that. I will show you that. But for now, this statement will taken care everything, right? If it acquires the lock, then it will execute the rest of the statement. And if it is not acquired the lock, right, then it will not execute the statement. And if you look at our previous example, right, then also the same thing is happening now behind the scene. Right, in the behind the scene, the same thing is going to be happening. Right, so you can see inside the try block, it is executing the monitor.enter method, and then it is writing the body statement. The same thing is we have written here. We are writing this monitor.enter, and we are writing the body statement. Here we are using the other overloaded version, which is taking only one parameter, but I will show you the example of this other parameter also.
Okay, so means like whatever is written after that monitor dot enter is considered a body, and other threads will not execute it until and unless that lock is released or it is false.
Exactly.
Okay, okay.
Okay. So this is how the monitor.entered method and monitor.exit method work, right? So at any given point of time, only one thread will allow to enter into the critical section. And at the same time, other threads are there in the waiting list, waiting queue, right? So this is what you need to understand, right? Then how does the monitor class work in C#, right? To understand this, you need to understand these things. Right? So whenever the monitor.enter method is invoked, right? Whenever this statement is invoked, right? Coming to your point, what is your doubt that I'm going to clarify, right? Whenever this monitor.enter method is invoked, right? Then in that case, the thread will be there in the ready queue. So whenever we execute this monitor.enter method, the thread will be stored in a special queue. That queue is called as the ready queue. That means if multiple threads, right? If multiple threads execute this monitor.enter method, then multiple threads are there in the ready queue or not?
Yes.
Right? From this ready queue means what? They are ready to be executed, right? But when they are going to be executed, that is not yet decided. Out of all the threads from the ready queue, operating system will take one of the thread and will allow that thread to acquire a lock, right? Out of the threads, suppose currently 3 threads are there. Out of the 3 threads, one of the thread will acquire an exclusive lock. The thread which acquire the exclusive lock will come and execute the code only, right? So you execute this statement means what? That thread will be there in the ready queue. Ready queue means that thread is ready to be executed, right? The thread is ready to execute the critical section of code. But when, that is not yet decided. There might be one thread in the ready queue. There might be multiple threads in the ready queue. Out of all the thread, processor or operating system will take one of the thread and it will allow that thread to enter into the critical section. Once that thread enter into the critical section, that means other threads are there still in the ready queue or not?
Yes.
Right? Once that thread enter into the critical section, then that thread will execute all this code, right? And once that thread execute the critical section code, then you have to write this monitor.exit method, right? Once you invoke this monitor.exit method, then the current thread which is executing your critical section will be moved to the waiting queue list. That means the thread 1, suppose thread 1 currently executing, thread 2 and 3, they are there in the ready queue. Thread 1 execute this monitor.exit method. Then thread 1 will move into the waiting queue, right? What is this wait and pulse? I'm not talking, I will talk that also in detail, right? Once that thread move to the waiting queue, then from this waiting queue, it will send a signal to the ready queue. Hey, I'm done with my work. Now it's your turn. You can go and execute the critical section, right? Then once it sends the signal to the ready queue, then in the ready queue, there are 2 threads, 2 and 3. Then out of the 2 threads, one of the thread will acquire the lock and that thread is going to execute the critical section of code. And once that thread completes its execution, then he needs to call this exit method. Once he calls it exit method, then that currently executing thread will come into the waiting queue. And from this waiting queue, it will send a signal to the ready queue to continue the process. Is that clear?
Okay. So
Now,
like whenever the threads are there in ready queue, only one thread is allowed, but that thread will execute the loop completely and then it will hand over it to other thread. Is it the case, or it is just it is like
See,
a time?
first of all, in our example, 3 threads are there, right? 3 threads execute this monitor.log print numbers method. That means in our ready queue, 3 threads are there. Point number 1 is clear.
Yes.
But from this 3 thread, which thread to execute first, that we cannot decide. That will be decided by the operating system. Let's assume thread 2 got the chance to enter into the critical section. That means thread 2 acquire an exclusive log. So thread 2 will execute this log. What I'm showing here, this is nothing but these statements.
Yeah. So my
Thread
question
two-
is this only: like, if it enter the log, will it execute completely? Suppose my loop is going to loop 100 times. Will it loop 100
Yes,
times and then
yes,
it will
yes,
give?
yes, yes,
Okay.
yes, yes. So completely means this execution is completed current. So that is what I'm showing now. Okay, okay. Let me run this application once more. See, you can see 0, 1, 2, 3, 4. This 0, 1, 2, 3, 4 is nothing but your loop or not. In between your loop execution, is there anything is there? Any other thread is executing?
No.
That
Okay.
means completely it will say once if you are adding any loop, if you are adding multiple loops, multiple method call, all these things are going to be completed. And once the execution completed, right? So you just tell me when the controller will move to the try block. Do you think that in middle of the execution of this loop, the controller will move to the finally block, or once it executes this statement, the controller will move to the finally block?
Yeah, after completion of every line in the try, it will move to the finally.
Right? So the same process is happening here also. So in this case, once we call this exit method, then what will happen? It will send a signal to the ready queue. Any thread is there, then please go and try to acquire the log and execute the critical section code. Clear?
Yes, because why I asked this question is like in case of thread, no, the thread was switching the control depending on some time randomly. But here it is like once it is completed, then only it will give the control to other threads to execute it.
See,
Is it?
this is the reason why we are using this now to protect the shared resources.
Yes,
See,
yes.
if we are not writing this statement, then multiple threads simultaneously execute this for loop. Then in that case, we will get some unexpected output, right? To handle that, we are using this one, right? So the
Yeah,
previous
got it.
we have seen, if we are not writing this monitor statement, then multiple threads can simultaneously execute this for loop. But that is what we do not want. We want at any given point of time, only one thread to execute this piece of information. And this is the reason why we are using this thread synchronization mechanism or thread safety mechanism, right? So this example, what I have shown you here, this is taking only one parameter, right? But as mentioned, there are other overloaded version are also available where it is taking another parameter of Boolean type. And this enter method, what I'm showing here, this enter method is internally used by the lock mechanism. Yes or no? In our previous example, we have seen the lock is taking the parameter okay, let me open the document, and you can see it is taking the overloaded version, which is taking 2 parameters, right? And even you can also see here the ILDS import clearly saying that it is using the monitor class enter method, which is taking 2 parameter object, and a second one is a boolean ampersand. Ampersand means it's a reference type. That means we need to understand this method, how it works, we have seen. But we also need to understand this method, how this other overloaded version is work. And the exit method, it is going to save, right? Okay. So you can see this is the syntax, right? So first of all, you need to create the dedicated object, logged object. And here you need to create one Boolean variable. And by default, you need to make it as false, right? And then the same thing, monitor.enter method. And here you can see I'm writing I'm passing the first parameter as log object, but here the second parameter I'm passing as a reference parameter. So I'm putting this thread. That means this enter method, right? This enter method will set this parameter value, right? So currently 3 threads executing this enter method. Then out of the 3 threads, 1 thread will get the log. For 1 thread, this each log taken parameter is going to return true. And that thread, and here I'm checking. If log is taken is true, then only execute the critical section. And here also, before calling the exit method, I also need to check if the log is taken, then only exit the log. This is how you can you need to use this second overloaded version, right? Let me copy the code and show you this practically. Right. So in this case, okay. Because that the array concept, you will get confused. Let me copy this one. Right. So this is the code. Okay. Okay. Fine. So in this case, you can see, so this monitor.enter log print number, the same thing, but here we are additionally using the other overloaded version, which is taking the second parameter is a Boolean and parameter, and that is going to be a reference type, right? If you go to the definition, you will see that ref Boolean is log taken. And if you go to this, it occurs an exclusive log on the specified object and automatically sets a value that indicates the log, whether the log was taken or not. That means it is going to occur an exclusive log, and here this parameter is going to give you, or is going to tell you whether the log was taken by the thread or not. Out of 3 threads, only 1 thread will get that chance, right? Okay, and the rest of the thing is same. If log is taken, then this parameter is going to return you true. If log is not taken, then this parameter is going to return you false, right? And the rest of the code is same. And here I'm also using the same concept, right? If log is taken, then only exit the log. If log is not taken, then why I'm going to exit this one, right? So this is the reason why I'm using this if condition, right? Now, if you run the application, then you will also get the same output as the previous example. Right? So you can see the same output as the previous example. Right? So out of the 3 threads, only for first 3 threads, one of the thread will get the log, and for that thread, this parameter value is set to true, right? And then for that, it is going to execute the critical section, and then it is going to execute the final block. And then once this log is released, right, then other threads which are there, they will get the chance to acquire the log, and for that log, again, the same thing is going to happen. So is there any difference, any query related to this? Here, we are just using this additional parameter, and this additional parameter is explicitly tell us whether the log is taken or not. Multi-threading and asynchronous programming, what is the difference? Yeah, see, don't come to that asynchronous programming currently, right? Asynchronous programming is altogether a different concept, right? Multi-threading and asynchronous programming are different things. And right, so when we need to go for multi-threading and when we need to go for asynchronous programming, that we will discuss in detail, right? In fact, after if you look at our course syllabus, right, then you will see that asynchronous programming is one of our main topic, right? So we are also going to discuss asynchronous programming in detail, right? After this multi-threading concept, we are going to discuss reflection, file handling, and collection framework. And then you can see our asynchronous programming, right? What is the difference when you need to use multi-threading, when you need to go for asynchronous programming, right? We are going to discuss all those things in detail, but not now, because if without explaining this asynchronous programming, it doesn't make any sense to make you understand what is the difference between multi-threading and asynchronous programming, right? Once you have very good understanding related to multi-threading and asynchronous programming, then you will understand when you need to go for asynchronous programming and when you need to go for multi-threading and what is the difference between them, right? So, but not now, right? So any question related to this example?
So just one question, like you use the overloaded version of that monitor.enter. Previously, we have not used that log taken or that parameter. Both are same, or will it?
Both are going to be same, but here as we are using this parameter, so explicitly you can specify this thing. If log is taken, then only enter execute this code. And this parameter is set to be true for the thread which occurs the log.
Okay, so the lock is taken will be true only for the thread that is got into the.
Exactly. Which
Uh,
the thread which occurred the log, for that thread, this which
it'll
log
it'll
taken
be
is going to be true.
okay. Okay. For others, it will be false
False.
always. Only when it will take, it will get true. Okay.
Yes, yes. The example is going to be same. There is no difference, but here we are just using this additional parameter, right? Now, so apart from this enter method, right, what we are using, so you will see there is something called try enter, right? Try enter, and if you see this object, what we are seeing in the parameter, this is nothing but your dedicated object. Time span means you have to specify the, and we have already discussed how to specify the time using time span and how to specify the time using milliseconds, right? Time spans and milliseconds. And what it will do, it will try to acquire the log within that dedicated time. Suppose you are invoking one thread and you are invoking this try enter method, and you are specifying that the time span is 100 or 1 second, right? In 1 second, if it acquire the log, then that is fine. Otherwise, it will go. It will not. Again, it will not acquire the log, and it will go forward, right? It will not acquire the log. And this reference boolean taken, what we have discussed now, the same thing, right? Let me explain you this with one example so that you will get better idea. So how this is going to be work. And you can see I'm going to use the overloaded version, which is taking all the three parameters, right? Monitor, the try enter, one object, timeout, and rep token, right? So I'm going to explain the example using this overloaded version, and for other overloaded version you can use, right? So instead of a millisecond, you can use time span, right? Without using this parameter, then you can also write the code, right? Okay, let me show you all these things practically. Right? Okay, so do one thing. Right? So here I'm using time span object, right? And you know how to use time span. In time span, it says there are lots of static methods, right? If you go to the definition of time span, you can see there are from days, from hours, from milliseconds, from minutes, from seconds. So you can use from milliseconds. I'm passing 1000, right? That means the timeout is 1 second per me. Even if you are not sure, so what you can do from from seconds. And here I'm passing 1 second. So we have already discussed this method. And the Boolean log taken as discussed, I'm making this as false. And I'm creating one private static read-only object, right? And the concept is same. Previously, I'm using enter method, passing 2 parameters, right? So if you compare this example with the previous example, then in previous example, we use this method. Yes or no? So here, this is my log object. That is what we have created here. And this is my rep token, log taken Boolean parameter, which explicitly tell me whether the log is taken by the current thread or not. If log taken, this parameter is going to be true, else it is going to false, right? And in this case, I'm not using this overloaded version. I'm using this overloaded version. And why I'm using this overloaded version? Because I'm going to use this timeout. Timeout means what? Now, 3 threads come here and 3 threads trying to enter the critical section. And what timeout we have specified? 1 second. That means in 1 second, if a thread acquires the log, then for that thread, this log taken parameter is going to be. After 1 second, but in between 1 second, if the thread doesn't acquire the log, then he will not, you will not acquire the log. So in that case, you can see he will come out. That means that thread will not get a chance to execute the critical section. In 1 second, if the thread doesn't acquire the log, then there is no chance that thread is going to execute the critical section code. In that case, what we are saying, we are just printing this statement, log was not acquired. And finally, if the log is taken, right, then we are exiting that, we are exiting or we are releasing that log, right? So this is the first parameter, that is the dedicated logged object. Timeout means we are providing one timeout, right? Within that timeout, it will try to acquire the log. If it acquires the log, then it will execute the critical section. In that timeout, right, within that time period, if it is not acquired the log, then it will not execute the critical section. But previously, they will be there, right? They will be there once the log is released, then they are going to execute the statement, right? But in this case, they are not going to wait for a huge amount of time, right? In this case, they are going to wait for this timeout. Whatever time period we have specified, the thread will only wait that amount of time. If in that amount of time they will not get a chance to acquire the log, then they will exit from the critical section, and the code what you have written here, that code is going to be executed, right? So in this case, you can see we are specifying 1 second is the timeout, and here it is going to execute, and here we are making the thread to sleep for 100, right? 100 millisecond. 100 millisecond means if this loop is executed for 5 times, that means the execution will be delayed by 500 millisecond, and for another thread, the execution will be delayed by 500 millisecond, right? Only execution delayed by 500 millisecond, but for executing this statement, right, executing this loop, they are also going to take some time. That means in 1 second, there is no chance that all the 3 threads are going to complete their execution. Maximum 2 threads will complete their execution, and one thread, you will see that that thread will not acquire the log, right? Let me run the application. Child thread 1 trying to enter into the critical section. Child thread 2 trying to enter into the critical section. Child thread 1 entered into the critical section. Child thread 3 trying to enter into the critical section. Child thread 1 execute the loop, right? Child thread 1 exit from the critical section. Child thread 2 entered into the critical section, right? Child thread, see, while executing the child thread 2, you can see 0, 1, 2, 3, 4. After 1 second, you can see child thread 3 log was not active, right? You understood this output or not? Guys?
means the overall time for all 3 threads within one.
See, not for overall time. For a particular thread, the time is 1 second. In 1 second, if he is not getting a chance to accept the lock, then he will come outside this block.
So
Not
this
getting-
means like the first thread which acquired has to complete within 1 second, and the second thread should get the chance. Then only it will enter that. Otherwise, it will come to else part.
Exactly.
Okay.
In this case, once the first thread which execute the critical section, that thread is going to take little more than 5 seconds, little more than 500 millisecond, because the thread is going to sleep for 500 millisecond. That means, and for executing this statement, it requires some time or not. That means it is taking little more than 500 millisecond for a thread to complete its execution, right? And once the first thread completes the execution, then the second thread will wait for 1 second, and in 1 second he is getting the chance to execute this statement. But while the second thread executing, that means 1 second is completed. 1 second is completed means the rest thread which was there in the queue, he will come out from this if block and he will execute this else statement. Clear?
Yeah. So after that, the thread which execute the else part will not acquire the lock again.
No, in this case, he will not get a chance. This is the reason
So-
why we are using this
Okay.
try enter method. Now, if you want all the threads to execute, right? Then why you are going to use try enter? You should use this method what I am showing here.
Okay, that means the queue is valid only for 1 second. Is that correct?
Exactly.
Okay.
In
Okay.
1 second, if he is not getting the chance, then he will not again get the chance to enter the critical section. You will just come out from the queue, right? Clear?
Yes. Yes.
Okay. Okay, we have seen this example, right? And one more thing, guys, in this case, I'm using time span like this, right? Even directly, you can also specify this, right? That is also fine. That is also fine, right? And even you can also use the other overloaded version, which is taking time in milliseconds. So if you go to the definition, you will see that I'm currently using this millisecond. Even you can also use this parameter, but right. So try to check all the overloaded version, but it is not mandatory because if you are using this one, then that is fine. Even nobody is going to use this one, right? Everyone using this one only, because no one want any thread to be skipped, but it's basically completely depend on your business requirement. If your requirement to execute all the threads, then you should not use this version, you should use this version, right? And if your requirement is maximum, some time allocation is there, if not completed, then just terminate the thread execution, then you need to use this version, right? Now, one of the important use cases of you can say monitor class is wait and pulse. So if you go to the definition of monitor class, you will see that there is some method called the pulse method, and there is a method called the wait method. There are multiple overloaded versions, but the concept is going to be same. I'm going to show you example using one overloaded version. For rest, you can check by yourself by changing the this parameter, right? So the wait method of the monitor class is used to release the lock on an object in order to permit other threads to lock and access the object. The calling thread waits while another thread accesses the object. The pulse signals are used to notify waiting thread about the changes to a locked object state, right? I know this statement, what I have written is not clear at the moment, right? But once I will make you understand the example, then you will understand what is this wait method and what is this pulse method is all about, right? Let us try to understand this with one real-time example, right? So I'm having two different methods. One method is going to print the even numbers like this, 0, 2, 4, 6, 8. And another method is going to print the odd numbers like 1, 2, 1, 3, 5, 7, 9, right? And what my output is, and what I want in the output is, I want the output like this. And in this case, one thread is going to execute this even number functions, and another thread is going to execute this odd number functions, right? And if I allows, if there is no inter-thread communication, then it is not possible to get the output like this, because once thread completes its execution, then only other thread will enter the critical section and execute the code. But if that is the case, then we cannot get this output. Then what is our requirement? Now, once I print this 0, then I want this thread to wait, and I want this thread to send a signal to thread 2 so that the thread 2 can execute or continue its execution. Once thread execute this 1, then that thread needs to wait, and that thread needs to send a signal to this T1 thread so that T1 thread continue its execution and will print this value. And in the same way, the process is goes on, right? Then how we can implement this? To solve the above problem, we need to use the signaling mechanism which is provided by the monitor class wait and pulse method, right? So in the following example, we are going to use the wait method to make the thread waiting and the pulse method to signal other thread. Then what is the process? The process is like this. So which value you want to print first? You want to print 0. 0 means, first of all, the even thread should start, right? Because if even thread will not execute first, then we will not get this 0 as the output in the first place. So first you need to make sure that even thread will start to print the number on the console. Then the even thread will signal the odd thread. So once it print the even number 0, then this even thread will make a signal to the odd thread. Hey, odd thread, be ready. Hey, odd thread, be ready. As soon as I am going into the waiting state, you need to continue your execution. Then how to send the signals from one thread to another thread? By using this pulse method, right? So once this event thread call this pulse method, so it will send a signal. It will send a signal to the other threads to be ready to print the number, right? And then when it calls the wait method, right? As soon as it calls the wait method, the event thread will release the log, and the event thread will move into the waiting queue, right? It will move to the waiting queue. And once it releases the log, and once it is moved to the waiting queue, already it is informing to the other thread, right? To be ready to start your execution, right? And then once it goes to the waiting queue, right? Then the other thread, which we have already sent the signal, that thread will start its execution, right? You can see first event thread start, second event thread send the signal to the odd thread to be ready for printing the number, and then the event thread will call the wait method, which allows the current thread to be blocked, and which allows the current thread to move to the waiting queue, which allows the other thread to start its execution, right? And the other thread will also do the same thing. The other thread will start printing the number on the console. Once it prints the number on the console, then the other thread will send a signal. Other thread in the sense odd thread. The odd thread again will send a signal to the event thread to be ready to print the number on the console. So how it is going to send the signal? The same mechanism, the monitor.pulse method, right? Once it sends the signal, right? Once it sends the signal, sending the signal means now the event thread is ready to be printed. But when it is going to print the number, when it got the log, then how it is going to get the log? Now once we call the monitor.wait method, then the odd thread will be in the waiting queue. All thread will release the log, and as soon as it releases the log, then the event thread is going to start its execution. So in this case, one thread, once printing the number, will send a signal to other thread. Once it sends a signal to the other thread, the other thread will be ready, right? And then the thread will call the wait method. And once the thread call the wait method, then what will happen? That thread will be moved into the waiting queue. That thread will release the lock. And as soon as it releases the lock, other thread which we already sent the signal, that thread will start execution. And the second thread also going to do the same thing, right? And in this case, both odd and even thread are sharing the same console window to print the number. We need to put a lock on the console ID. We need the sequence to be started with the even number. So even thread must run fast. So how we'll make sure? Now before calling the second thread, we need to make okay, let me show you this practical. Okay, this is my print number, and this is my print event number, and this is my print order number. So what I'm creating my event thread, which is going to print the event number, and this is my odd thread, which is going to print the order number. And first I start this event thread, and after starting this, I make this thread sleep. So once I make this thread sleep, that means the current thread is sleep for 100 milliseconds. That means this statement, we are calling here, that statement execution is delayed by 100 milliseconds, and before that, this thread will already is going to be start, right? So in this case, I'm putting this sleep method to make sure that the event thread is going to start its execution fast. Then only the odd thread is going to start. This is the reason why I'm putting this sleep statement here. And then I'm calling this join method on the event thread and calling the join method on the odd thread. So why we are calling the join method? To make sure that this statement is going to be printed after the child thread completes their execution. So join method means what? It will block the current thread until the child thread completes its execution. In this case, this join method block the main thread until the odd thread completes its execution. This join method block the main thread until the event thread or the child thread completes its execution. Once both the thread completes their execution, then only this statement is going to be printed. And in this case, we are going to print the number, like we are going to print the number from 0 to 20, right? So 0 to 20 output like this, and we want the output from 0 to 20. And for that limit, I'm putting this number limit. If you want 0 to 100, then you have to provide this number as 100. If you want to print 0 to 50, you have to provide this number as 50, right? So this is your number limit. Up to what number you want to print on the console. And then this is nothing but your dedicated. Then this is nothing but your dedicated object, right? Lock object. That lock monitor object is going to be used by the monitor, right? And this statement main method I have explained. Now let us come to the main part. So first, which thread is going to start? First, event thread is going to start. Event thread pointing to which method? Print event numbers method. So first, this method is going to start. So this is the statement monitor.enter log monitor. So as soon as this enter.monitor.enter method is invoked, right? That means this code block is nothing but your critical section. As long as this code block is not completed, it will not execute. It will not allow other thread to use this lock monitor object. And if you see, this lock monitor object is also going to be used by this other thread, right? That means this lock monitor, this thread is not going to be executed as long as this thread which is currently using this lock monitor instance executed. But the problem is that if we are allowing this thread to complete its execution, that means it is going to print the event number. So 0, 2, 4, 6, 8, 10, but we don't want that output. How we are going to want the output? We want the output like this sequence 0. So output should be like this. Output like this. So first 0, then 1, then 2, then 3, then 4, like this. So in this case, what is required? Now, after executing some code, right, we need to tell the other thread, that is print number thread, to continue its execution. Yes or no? If we are not informing other thread to continue its execution, then how we can print this 1 before 0 and 2? How we can print this 3 before 2 and 4? That means we need to continuously, concurrently execute this print number method as well as this print order number method. Right. So for that, what I'm going to do, I'm just using this for loop, and you can see I'm using this I plus 2 means every time the loop variable is incremented by 2. So 0, 2, 6, 8, and it will come as long as this I value becomes 20. And once I value becomes 20, this condition is satisfied. Next time I value becomes 22, this condition will not satisfy. Right. So here what I'm doing is I'm printing the number, right? After printing the number, what you need to do? You need to notify the other threads. You need to notify the other threads who uses this log monitor dedicated object, right? Is there any thread who using this log monitor object? Yes. This thread, this print number thread using that log monitor object. So by executing this statement monitor.pulse, what we are saying now, we are informing other thread. In this case, we are telling to the print odd number thread, right? Print odd number thread, be ready to continue your execution. Be ready to continue your, or be ready to do your job. I'm done with my job. I'm sending you the signal, be ready. Be ready means what? Be ready means it doesn't, he will continue the execution as long as we call this method. The meaning is not that. The meaning is be ready because the object state is going to be changed, right? This is the log object state. The log object state is going to be changed. Be ready. As long once I call the wait method, this thread, right, the currently executing thread will be moved into the waiting queue and will be released the log on this object so that you can continue your execution. So in this case, right, in this case, we are sending the signal to the other thread to be ready to continue your execution. And as soon as we call this wait method, the current thread will be go into the waiting queue. The current thread will release the log on this log monitor object, and as soon as it release the log on this log monitor object, right? So in this case, you can see I'm calling this monitor this method. So not log monitor, it should be like this one. So as soon as I call this wait method, so the event thread, right? Event thread will move into the waiting queue. The event thread will release the log, and once the event thread release the log, then previously we have already informed the other thread to be ready to continue your execution. That thread will get the log, that thread will acquire the log, and that thread will continue the execution. Understand the point or not, guys?
Yes, sir, understood. But like in the main thread, while you are calling, why you making it sleep? That I didn't get.
See, here I'm making this, I'm calling this sleep method to make sure that event thread will execute fast. If I'm not making, if I'm not calling this sleep method, that means simultaneously these two threads are started. Then processor will decide to, then the operating system maybe start this thread first. Thread means maybe start this execution first, or maybe start this execution of this print odd number method first. But I want that this thread to be executed first. I want this print number method to be executed first. This is the reason why I'm delaying this execution, delaying this thread the sleep. Thread the sleep means it will delay the main method execution for 100 seconds, but 100 millisecond. And in that 100 millisecond, that child thread is going to be start its execution, and then only the odd thread is going to start. To make sure that even thread will execute fast, I'm making this thread dot sleep.
Okay, thread dot sleep will only affect to main method, not the method, not the threads that are executing right now.
Exactly. So you are calling this thread sleep method means it will block the execution of a main thread only. It will not block the execution of child thread. So here you are creating that child thread. Here you are calling the start method. That means child thread execution will be going on. And here you are calling this thread sleep method means main method execution is sleep or it's delay by 100 millisecond. And after 100 millisecond, it is going to execute the next statement. And once the next statement is executed, this print odd number method is going to start. And before that, this method execution is already started. To make sure this method will start fast, so we are calling this a thread.sleep method so that it will delay the execution for 100 milliseconds. Clear?
And one more thing, so regarding that join, anyhow you are alternatively printing those numbers in the respective
Exactly.
threads.
See, my intention is I want to print this main method execution completed after the output. So if see, you can see once the number are printed, then only I need to print this statement. If I'm not calling this, it might be possible that 0, 1, 2, 3, 4, then main method completed, then 6, 7, 8, 9, 10. You might be get the output like this. So to make sure the output in a proper sequence, I'm calling this join method. And once the child threads completes their execution, then only this statement is going to execute.
Okay.
Clear? Any question from anyone else? Okay, fine. So in this case, if you write like this, then the thread will be wait forever, right? So we need to write some logic here. Logic, what is the logic? So what I'm doing here, I'm checking whether the number, right? Whether the number limit. So whether the I value is the last one in the sequence or not. If I equals to number limit, that means this is the last loop, right? So when I value becomes 20, that means this is the loop. This is the last execution of the loop or not. The loop will execute until the I value becomes 20. When I value becomes 22, is the loop is going to execute anymore? Guys, tell me.
No.
No. That means here I'm writing this if last false and if I value equals to 20 and then only it is going to be the last iteration. And if it is not the last iteration, then only wait for the monitor. And if it is the last iteration, then don't wait. Understand my point? Because if I value becomes 20, then why I'm going to wait for the other thread to give me the signal, right? If I value becomes 20 means I do not want to wait. The execution is done. The thread is not going to wait for the other threads to complete, right? That means the execution is completed. And this is the reason why I'm putting this logic here. So if I value becomes not, if I value is not last, then only wait. If I value is last, then don't wait, right? So if you write this logic here, then it will wait forever. But I don't want to wait forever. I only want to wait as long as the I value not becomes 20. And as long as I value becomes 20, I'm not interested for waiting anymore. So in that case, it is not going to call this statement. Right? So this is the logic I have written here. And the same thing you will find in print odd number method. So here it is going to start from 1. Again, it is incremented by 2. And again, it is going to print the value as long as this condition satisfied. Right? Again, it is going to send the signal to the other threads by using the lock monitor. And again, I'm not going to use this wait monitor because I have to write the logic. Right? This is the logic. I value is last. Number limit -1. So the logic I have written here, and within this logic, right, it is not going to wait forever. As long as the I value become the last, it is going to complete the execution, right? Now, if you run the application, then you will see that the output as expected. So basically, false method is used to send a signal to notify the other threads, be ready to continue your execution. And when we invoke the wait method, right? When we invoke the wait method, the thread is moving into the waiting queue. The thread is released release the lock so that other thread can continue its execution. And again, we are not calling the exit method here. We are calling the wait method, means again it can reactivate the lock, right? So you might be one question, sir, what is the difference between this wait method and exit method, right? So if you go to the exit method, means it release the exclusive lock, right? Once it release, it cannot reactivate the lock, right? But if you call the wait method, the release the lock and object currently until it reactivates the lock, right? Again, it reactivates the lock if you are calling the wait method, and if you are calling the exit method, then it cannot reactivate the lock. So in this case, you can see it is sending the signal, making the threads to be waiting, right? Making the thread in waiting queue, releasing the lock, again reactivating the lock. When it is going to reactivate the lock, when other thread going into the waiting queue, and when other thread release the lock, then at that time again it will reactivate the lock. Clear? And finally, once all the execution completed, then only you need to exit the lock, right? Any question from anyone related to this program?
Sir, I think in the loop, no, when it reaches 20, it will not enter even the loop. I think.
See, when it reaches 20, so that will be completed now. But in that case, if you are calling this wait method, then it will wait, right? So in this case, okay, to make you understand, if I'm calling this wait method, right? So if I'm calling this wait method, then in this case, it will wait until it receives the signal, right? And once it receives the signal, and once the other thread move into the waiting queue, then it will continue the loop. But as long as it is not getting the signal, then it will be wait forever. This is the reason why I'm writing this statement, right? If it is the last statement, then it will not wait, it will complete the execution, right? Clear or not? See, once the statement what you have written inside this statement block is executed, then the loop, the next iteration is going to happen or not? Do you think that after executing this statement, without executing this statement, the loop iteration is going to happen?
No, it will not happen. So
That
actually,
means-
my doubt is like, suppose here only in for loop only we are checking. No, we are validating that if I is less than number limit, then only we execute all this logic. If I becomes 20, it will not execute the logic itself. No?
See, but I becomes 20 means, so before executing the next iteration, first of all, it need to get the signal from the other loop. No? So what is the use of then in that case, you might be question me, what is the use of this two statement? I cannot, I can comment this, right? So if you are using this log.monitor or monitor.false, means it will, when this statement is executed, it will not execute the for loop. It will wait when the other thread sends the signal. So once it gets the signal, when this statement is executed, the thread is release the log or not? The thread is in which queue?
This is in waiting queue.
Right? That means if the thread is not executing, do you think that the next iteration is going to happen?
No.
This is the reason why we need to write. So in this case, when it is not the last one, then I'm not calling this method. If I'm not calling this method, means it will come out from the for loop and it will execute it. If I'm not if I'm not checking this statement, if I'm directly writing this, right? That means when I value becomes 20, right? When I value becomes 20, again it is going to send the signal. Again, it is waiting for the signal or not.
Okay, okay. Got it.
And in that case, it will never reach, it will never get the signal. That means it will be there in waiting mode forever, right? So
Okay.
waiting means that means the thread is already in sleep mode. The thread is released the lock. You cannot execute, right, until and unless it gets the lock. So this is the reason why we are checking this. If it is the last one in the, if it is the last number, then don't wait. And how you can make sure it is not going to wait? By putting this condition. Clear?
Yes.
Okay. So this is how the lock and monitor work. The difference between monitor and lock is that lock internally wraps the enter and exit methods in a try-finally block. Internally wraps the monitor class enter and exit method in a try-finally blocks with the exception handling, right? Whereas for the monitor class, right, no, it is not handling the exception, right? Finally blocked. Whereas for the monitor class in C#, we need to use the try and finally block explicitly to release the lock. So in this case, you can see explicitly we are writing the code to acquire the lock, and explicitly we are writing the code to release the lock. So lock equals to monitor plus try finally, right? The lock provides the basic functionality to acquire an exclusive lock. See, lock means you can only use lock, and in that case, it is going to use. Okay, let me open the documents. Lock means it only provides the basic functionality, right? Basic functionality means that there is only enter and exit method. But if you want to use the advanced functionality like pause, like try enter, like wait, then you cannot implement those things using the lock. And in that case, your only one option is monitor, right? So using monitor, you can only implement this mechanism, right? But if you want to use this mechanism, then you cannot use lock. Lock means only the basic functionality, right? Now, the limitation of lock and the monitor. Locks and the monitor help us to ensure that our code is thread safe. That means when we run our code in a multi-threaded environment, we do not end up with inconsistent result, right? So in this case, you can see this is your critical section code. And in this critical section, there are many internal threads are there. And out of all the internal thread, only one thread can access your code block. That is what we have seen using lock and monitor. That is fine. Then what is the problem? There are some limitation to lock and monitor. The lock and monitor ensure thread safety for threads that are in process. The thread safety for threads that are in process. What is in process means the threads that are generated by the application, or you can say internal thread. If it is an internal thread, then the lock and the monitor will control this. But if the threads are coming from external application out of a process or external threads, then the locks and the monitors have no control over them. So in a situation like this, we need to use mutex, right? We will discuss that. So for example, okay, just tell me which thread is going to execute your main method. Guys,
Main thread.
Main thread.
main thread is our internal thread or it is the external thread?
Internal thread.
Main thread is internal. Do you create the main thread in your code? Or main thread is provided by the process and operating system?
Process.
Yeah.
Then how it will be your internal thread? The thread which you are creating in your application is going to be the internal thread, right? So in this case, this even thread, this odd thread, it is going to be your internal thread. But the main thread, which is executing your application code, right, from the main method, that is going to be your external thread, or you can say the thread which is provided by the process, right? Main thread is not your internal thread, that is external thread, right? And there is no control. So the lock and monitor, what we have written here, they will control the internal thread only. They do not have any control over the external thread. For example, if I go to this folder, right, and bin debug, and if I click this main thread, one external thread, execute our application. Another time I click on this ex file, another external thread execute our application code. In this case, you can see another external thread execute our application code. That means currently 3 different processes are there, 3 different external thread are there who is executing our application code. To prove this, you can go to task manager and you will see that threading demo. My application name is threading demo. So each application is going to be executed by a separate process. So currently my same application, right, I clicked 3 times, so 3 different processes executing the same application code. And there is no limitation, right? You cannot control this. If you want that once I click on this application, once my threading demo 1 application is running, then no other external application can access my code, right? And in this case, as you can see, in this case, you can see all the 3 different threads accessing my application code, right? All the 3 different external thread accessing my application code. Yes or no?
Yes.
But if you want to restrict that once one external thread access my application code, and if another external thread trying to access the application code, it should not happen. We should not allow more than 1 external thread to access our application code. Then in that case, you cannot use lock and monitor. Lock and monitor only manage the internal thread. They cannot manage the external thread, right? And if you want to manage how you are going to control this, now for that we need to use something called a mutex, something called semaphore, something called semaphore sleep, right? So in our next session, I mean tomorrow, we are going to discuss what is mutex, what is semaphore, and what is semaphore sleep, and how we can manage this external thread. So suppose you want that only 1 external thread should allow your application code, we can do this. If you want that 2 external threads should allow to execute my application code, but more than 2 external threads should not allow, that I can also manage, right? So if you want that you written some code and in your application, and you want that more than 1 internal thread should access the code simultaneously, that is also possible. We'll discuss semaphore sleep. So these 3 things we are going to discuss tomorrow, right? Any question from anyone from today's session?
Sir, one question. Like, why do we need to restrict the main thread accessing, like multiple threads accessing the main thread? Because our internal code can be accessed by any number of times. Is there any necessity?
See, suppose you are developing one application, right? And one desktop application you are developing, and you are providing that desktop application to the client, right? And your requirement is that maximum 3 clients can access the application. If more than 3 clients trying to access the application, they got the license for 3 users, right? And that means at maximum 3 users can access your application code. But if they are trying to access more than 3, then it should restrict. Then in that case, you need to use this external, then you need to restrict this external thread.
Okay.
Right. So it's basically depend on your business requirement.
It's like we get, suppose for these applications like Amazon Prime and thing, they will provide us like it can work only in 3 devices.
Exactly.
Will it be the same like this?
Exactly. Suppose you are suppose I'm buying license for my Zoom credential, right? Zoom link. I'm buying a license for 1 user. 1 user means at any point of time, only 1 user can use the Zoom credential, right? If it is allowing you to schedule multiple Zoom training meeting at the same time, then it is a loss to them now, because I'm buying 1 license, but at the same time I'm conducting 3 different meetings. This should be restricted. No? So how you can restrict by using this one?
Okay. Got it.
Got it?
Thank you.
Yeah. Any question from anyone else? Okay, that's it for today. And tomorrow we are going to discuss few more important concepts. So please attend the session, because I'm not sure when the new session is going to start, because my health is also not that good, and I'm also having 7 days. I mean 7 to 8 days sleep. So there are lots of work to be done for my company, right? And even one batch MBC and WebAPI batch, right? One person started, but it's not up to the mark. So I need to continue that batch. So for that also I need to give time to that batch only. So I'm not sure when the new C# training batch is going to start. So please join this session as much as possible. Right. Okay, that's it for today. Thank you for your time.
Thank you.
Thank you, sir.